Hello guys, it's Elliot here from EVXodio. That's how you pronounce it if you're wondering. And this episode of Science in Minecraft is not about proton beams, it's about neutrinos. Now, you might have heard of them, probably have, because they were thought of to be faster than the speed of light, which is thought to be impossible. So that's why they are pretty interesting. So basically, what neutrinos are, I'll go into a bit of the history of neutrinos, or not history, but what they are. Neutrinos are subatomic particles. Now, these neutrinos basically make up protons. So they're little subatomic particles that are inside the protons, and if you didn't know, protons, neutrons, and electrons make up an atom. So they're extremely small, and really, you would never, ever be able to see it with your own eye, except if you had a really good microscope. Okay, so we're just going to talk about what the experiment that happened and what people have been talking about. Now, there was this experiment that Opera, I believe they're called, had, where they shot these subatomic particles, neutrinos, through a, let me just turn it to sunrise, through a graphite target. Now, I'll get into that in a minute, but basically, people think that these neutrinos are some really weird particle that they've never experienced, but actually, there's billions and billions and trillions and so many everywhere. There is literally, apparently, 65 billion pass through every square centimetre of our planet every second, which is absolutely crazy when you think about it. So they are constantly among us, but just really hard to see. Okay, so we're going to get into the experiment here. So what they did, because actually, let me just talk about the speed of light. So the speed of light is 300 million meters per second, and that's thought to be, the limit of how fast you can go in the universe. But neutrinos have been thought to go faster than 300 million meters per second. Okay, that's a crazy thought, and this is how they found it out. Okay, so right, let's get into the experiment that they did. So basically, people know what neutrinos are now, but how do we get neutrinos? Well, basically, what they did is they've got a proton beam at the CERN. I don't know if you've heard of CERN. You probably have. Ages ago, it was thought that it was going to create a black hole or something, which is very stupid. But yeah, so basically what they did at first is shot a proton beam into this graphite target. Now, graphite is, I believe, a type of carbon, so it's special and can split particles up. So these are protons in this proton beam, and they go straight through the graphite target, and what that does is splits them up into two different particles. These, well, subatomic particles. These are called kaons, which are represented as blue here, and pions. So they're shot through this graphite target and split up into these orange and blue kaons and pions. And what happens here is, whilst they're going through this 1 kilometer tunnel in CERN, to end up going to Gran Sasso, which is where the experiment finishes, the pions and kaons decay slightly because they're going so fast in this kilometer long tunnel that they've shot them through, and they decay into these two things. Now, I've got a representation here. So this is a kaon, and this is one decaying into muons and neutrinos, and neutrinos are shown with obsidian, because I think obsidian is the best kind of way, because everybody thinks that they're purple, even though there's probably no colour to them. I don't even know. So yeah, muons and neutrinos are decayed, and then they keep going, and they're the only things, because they're so small, they're the only things that can get through a metal wall. So what they set up next is a metal wall in which the neutrinos and muons can go through. However, the kaons and pions just rebound and go back, so they can't pass this metallic wall made up of graphite and metal. So they pass through there, and then what you get is all these muons and neutrinos, and what they need to do, and slimes at the moment. And what they need to do now is split up these muons and neutrinos to make just neutrinos. Now, one special thing about neutrinos is that they can go through the Earth's crust simply and easily, because they have hardly any mass at all. So almost no mass at all. It's pretty crazy. Also, they have no charge, so they're not positive or negative like electrons and protons. They have no charge, so they're not affected by magnetism, so they don't get pulled by any force like that. The only force that affects them is this little small force, weak force it's called, something like that. Yeah, so then they basically they shot them through the Alps, basically, and the Earth's crust, because they can pass pretty much unchanged through the Earth's crust, and then all you get is neutrinos. So that's how they split neutrinos up. And then there's a massive machine. I don't really know how the machine works, because that's a bit too far, but this machine detects the neutrinos hitting, and basically what they detected at Gran Sasso, which is where the experiment ended, which is actually 732 kilometers away from CERN, where it started. What they found out was that these neutrinos had actually travelled faster than the speed of light, and they had actually reached here 60 nanoseconds before the speed of light would have travelled here. So yeah, this is, I mean, they've been trying to look for problems in this experiment for ages, but they haven't found any. So at the moment, it's looking like Einstein's theory of special relativity has crumbled. So what I'm going to talk about next is basically what this means. Now, neutrinos, because they've, questioned Einstein's special relativity, and questioning that, maybe stuff can go faster than the speed of light if it has mass, then it makes the universe incredibly shrunk. It doesn't mean that we can travel there, obviously. We might in the future, but it doesn't mean that we're gonna instantly be able to travel. All it means is this might mean that there's some way that, like using radioactive waves or something new, or neutrinos, even if we can assess the impact of neutrinos, we can go further into the universe than we've ever gone before, and we can, see if, even Einstein's theory of if you keep going in the universe, you'll end up back where you started. We can try that. It's endless possibilities. It's quite crazy if you think about it. Yeah, so that's neutrinos. That's about the end. I don't think I have anything else to talk about with you, except that they are crazy find, and if it's true that they do go faster than the speed of light, it will be amazing. Now, there's one little thing I want to talk about, is people about the dimensions, and that some people think that the explanation for these neutrinos going faster than the speed of light is actually that they somehow go through another dimension and end up somewhere else. Now, that's going into another subject, but if you think about it, what people think of the dimensions, just a quick overlook of dimensions and how neutrinos could cut through dimensions. What people think about it is like, you know how there's 2D on a piece of paper. If there was like a 2D world, it lives in a 3D world, and that 3D world can be can bend the 2D and get it closer in the 3D world, but in the 2D world they're not closer because they have to go round. I don't know if you're understanding me, but so what they're saying is maybe that the 3D world is like, say, a 2D sheet of paper bent. The 3D world, people can stuff like neutrinos can actually cut through the fourth dimension, which is crazy if when you think about it, and actually end up back in the 3D dimension without any scratches. So yeah, that's something to get your brain around. That's going to be the end of this episode. Thanks for watching. This has been EV Exudio, and yeah, subscribe if you'd like to learn more and about these amazing wonders that I've always wanted to know, and now I get to share the knowledge with everybody in YouTube. And also, if you like the video, obviously like it, it's pretty obvious. And yeah, bye.